Hello everyone. Today we will discuss uncertainty principle. The uncertainty principle, it is very important in quantum mechanics. All the quantum mechanics is based on this uncertainty principle, and it makes a clear picture how quantum mechanics is different from classical mechanics. So in the classical mechanics, with the help of Newton's law, we determine the position and momentum of the particle very precisely. To know the position and momentum of the particle in classical mechanics or in Newtonian mechanics, we must know the position of the particle at time t equal to 0 and the force applied on the particle. On the basis of these facts, we can determine the path of the particle in classical mechanics. So finally we set the equation of motion from the Newton's law, force equal to mass into acceleration, so it can be written as md square x upon dt square. So with the help of this equation we find the trajectory or path of the particle, which is known. On the other way you can say we find out the equation of motion. So on the basis of that equation of motion, we determine the position and momentum of the particle at any time t. So in quantum mechanics, we are not dealing with the certainties, we are dealing with the uncertainties. How this uncertainty comes into picture? Due to the wave particle duality. That means at the atomic realms or the microscopic particles or the elementary particles, they show their dual character. They possess, so suppose we have n number of particles. From the principle of superposition, we find as a wave packet. Suppose the wave function for this particle is psi 1, psi 2, psi 3 and so on, psi n. Finally, we find the wave packet. That means particle is localized somewhere in this region. But in classical mechanics, the position of the particle is precise. Suppose particle is at point P in the xy plane. So the position coordinate of particle x and y. So there is no uncertainty delta x in finding the position of the particle, but quantum mechanically, due to wave particle duality, the position of particle is not certain, that is delta x. So Heisenberg stated a principle which is known as Heisenberg uncertainty principle or the uncertainty principle. According to this principle, it is impossible to measure both the position and momentum of the particle simultaneously. Or you can say that it is impossible to measure simultaneously and precisely both the position and momentum of a particle. So you can write this statement as delta x, delta px is greater than equal to h cut, where delta px is the x component of the momentum. So delta represents the uncertainty in momentum, and here delta represents the uncertainty in position of the particle. So this statement means if we try to measure the position and momentum of the particle simultaneously, then the product of uncertainties in position and product of uncertainties in momentum cannot be less than h cut. So this equation can be rewritten as delta px is greater than equal to h cut upon delta x. So if delta x is 0, delta x is 0 means particle is at somewhere like in classical mechanics. That means particle is completely localized. Not in this region, it is at a certain position like in classical mechanics. Then delta x equal to 0, that means particle is completely localized. In this case, our equation can be written as h cut upon 0, so it is infinite. That means the uncertainty in a momentum is infinite. That means the momentum of the particle is completely unknown. Now if delta px is 0, that means momentum, uncertainty in momentum is 0. That means momentum of the particle is known. Then from this equation we can write it as delta x equal to h cut upon delta px. Since delta px is 0, so h cut upon 0, so it is infinite. That means particle is completely unlocalized. Thus, the knowledge of x or px, that is position or momentum, can be obtained only at the expense of the precision of the other. So these uncertainties are not due to any technical fault in the measurement. During the experiments, there are certain errors in the experimental data. If we try to reduce these errors to 0 or to minimum, even then there is uncertainty in position and momentum of the particle. So this uncertainty is not due to any experimental measurements. This uncertainty is due to the dual character of the particle, elementary particles, microscopic particles. So the important thing we find out here is the uncertainty principle indicates that we cannot precisely find the position and momentum of the particle. Hence the concept of trajectory or the path has no meaning in quantum mechanics. Thus, the picture of the motion of particle in quantum mechanics is completely different from the picture of motion of particle in classical mechanics. So, it must be noted that the uncertainty principle put no restriction on the accuracy to which x or px can be determined. It restricts only the simultaneous measurement of both x and px, that is both position and momentum, such that delta x equal to 0, and delta px equal to 0 at the same time.